All right, everybody. Welcome to day one of Algebra 1 with Mr. Carmona. So, before we get started on today's lesson, I wanted to go ahead and give you guys just a little bit of background information. The reason why I want to do that is because there are a couple of things that we're going to go over today in our actual learning that I want to make sure that you guys completely understand. So, first thing I want to talk about is exponents. So exponents are just kind of a shortened way to write things that are multiplied together that are the same thing. So let me give you an example. Let's say I wanted to write this out in shorter form. So instead of saying 2 times 2 times 2 times 2, I would instead say 2 to the 1, 2, 3, 4th power. Sometimes written like that, if you were typing it into a calculator, maybe a computer. So the alternative way of thinking about that is this number here, also called my exponent, tells me to take 4 of my bases and multiply them together. So for example, 3 to the power of 3. That means take 3 3's and multiply them together. Or if I had something like 4 to the power of 2, take 2 4's and multiply them together. This also works with variables. So I can even write something like x to the power of 10. That'd be x times x times x. Right? So instead of writing out all of that, I could just write out x to the power of 10. It just saves me time. It's a shorthand way of writing it. Now, based on those exponents, there's also something called standard form of an equation. While of course there are specialized versions of this for different things, most of the time it's going to be in alphabetical order. And the exponents are going to go down. Okay? So what that means is, for example, if I saw something like x to the power of 5 plus x to the power of 6 plus x to the power of 2 plus y to the power of 2 plus a to the power of 2. First, I would say, all right, which one of those comes first in the alphabet? Well, it's going to be my A, so I'll write that guy first. Now I'm going to say which one comes next, the X. Well, there's a whole bunch of those guys. Here, here, here. So I need to first look which one has the largest exponent, the biggest number at the top. And that's this guy. So I'm going to write him first. Now I'm going to look for the one with the exponent that's below that. I have a 5 and a 2. 5 is larger than 2, so I'll write that one. And then my 2 is last. And last in the alphabet, in between these 3 letters, is my Y. So, no matter what you're doing, usually standard form is going to mean alphabetical order, A, B, C, D, E, F, G, and going exponents that are large to small, biggest to smallest. All right, let's go ahead and get into today's lesson. So, first thing, we're going to be talking about combining like terms. First, let's talk about what the different pieces of a term are. First thing, I have a variable here, okay? And that variable has 2 different pieces. It has the base, the letter part, that could also be a number for any exponent, and the exponent. anything that's attached to the front of a variable or something that's in a parentheses is called a coefficient. That's a fancy way of saying the number that's in front of it. If we have a number that's by itself, that's called a constant. It's not changing. I want you to notice something. Notice variable, constant. Variables change, meaning they can have different answers. Constants do not. They're one set number. Also, I'd like you to be cognizant of the fact that this constant has a negative. So if I ask you what the constant is, you would say -5. That's a part of that number, okay? Now, on the whole, if I look at this unit as an entirety, 3x squared minus 5, that is called an expression. Why is it called an expression? No equal sign. If I had an equal sign and it was something I could solve, that would be an equation. Okay, so let's go ahead and start filling in these blanks. And these are going to be found in your OneNote that you can write in as well. So let's talk about combining like terms. When I say the word like, I mean the same. That means terms that have the same variable raised to the same exponent. So that means they have the same exponent, number at the top, and they have the same variable or base, the letter component. So things that would be considered like terms would be something like the pair 2x squared and x squared, y to the power of 4 and 3y to the power of 4, and even stuff like 10a to the power of 10 and 2a to the power of 10. Noticing the pattern here. So let's go ahead and go through and make sure we understand that. They have the same, make that a little smaller. They have the same base, the letter part, and they also have the same exponent, the number at the top. Again, they have the same base, this variable y, the letter part, and the exact same exponent, the number at the top. Same exact thing in the last situation. Same letter, variable, base at the bottom, same exact exponent at the top, 10. So noticing, we don't care what the coefficient is. What we care about is they have the same base and the same exponent. Now, these coefficients do not have to be the same. So that means that I can take my 2 and my 1 and they can combine together to make 3. Coefficients, in my mind, are something like a counter, right? Let's talk for a second about that. So if I said 10x, 9x, that means that I have 10 x's that are adding together, 9 x's that are adding together. And I'm just writing it like that, so that way I'm not writing x plus x plus x plus x plus x. Okay? So, my constants, the numbers that are by themselves, are also considered like terms. So examples might be 5, -9, +10. All of those I can put together and I can add together.
Another rule of thumb is to think about it like this. They only like to be with somebody who's exactly like them. Plain, regular numbers, constants, only like to be with other constants. X to the power of 2 only likes to be with x to the power of 2. They don't want to be combined with x to the power of 3, x to the power of 4, y's, a's, anything else. Only other x to the powers of 2. So they only want to be with somebody who's exactly like them. So how exactly do we combine like terms? What that means is we're going to take something where we have x's all over the place, y's all over the place, numbers all over the place, and maybe even other variables all over the place, and we want to condense it down to make it easier to read. So I don't want to have to see something like 3x plus 5x minus 2x plus 10x plus 15x, et cetera, et cetera, et cetera. I just want to say, oh, 5x. I want them all to be together. So, some steps that people like to follow is you can draw a line in front of every sign. So if it has a plus in front of it, that plus stays with that term. If it has a minus, it stays with that term. We can color all the terms, all like terms, the same color. And I like to use shapes instead because sometimes you don't have the ability to do that. Put each group of like terms together and combine each group into one term. Rewrite the terms in order from the highest power to the lowest power. So that seems like a lot to me already. I'm going to show you the simplest way for us to do it. So let's take example number 3. Here they're asking us to find the perimeter of the figure. Well, let me think back for a second. Perimeter. That means adding up all the sides. So if I was just to write that out and I didn't know how to combine like terms, I'd say, well, 6x plus y plus x plus 3y plus y, right? That's a lot going on. So earlier we said we could color code them, or we could do all kinds of things and move stuff around, but I like to make this as simple as possible. I don't like to have to write a whole bunch of stuff, because then I get confused whenever I go back and check my work. So what I like to do instead is I draw shapes. So I do circles, squares, triangles, maybe a heart. Usually you won't have more than 4 different things to worry about. So I'll say, all right, let me first look. I want to write these in standard form. So alphabetical, and then exponent from big to small. Okay, so I'm going to look at all the different variables that I have. X, Y, X, Y, X. Which one of those comes first in the alphabet? Well, it's the letter X. So I'm going to go ahead and I'm going to start with my X's first. This X only has no exponent. Now, I'll tell you this ahead of time, even though we're not learning this yet, that really means that there's a 1 there, not a 0. It's a 1, okay? So if you don't see an exponent on something, it's really a 1. But we don't write that because we don't need to write that. We already know it. So I'm going to look for all my X's, and I'm going to circle them here, here, and that's it. Noticing that that X that had a plus in front of it got the plus included inside of its circle. Why? Because if that had been a minus, I wouldn't want to confuse myself and think that that's a plus X. So now that I found them, I'm going to add or subtract them together, okay? So positive 6x plus x, I have 6 here, plus 1 more. That means I have 7 total. When I'm done combining like terms, I'm going to cross them off. Okay, now I'm going to move on. I don't have any more x's to deal with as far as exponents, so I'm good with x. Next letter is going to be y. So I'm going to do a different shape, and I'm going to go ahead and color code this as green just to make it a little bit easier to see. Positive y, positive 3y, positive y. So 1 plus 3 plus 1, 5y. Let me cross those off, and it looks like I'm done. This is my final answer. I like to make sure that I either circle or box in all of my answers so they're easier to find. So just in case I need to type them into something to submit my answers, or so my teacher can see them, or if I'm showing my work to somebody else and trying to help them. Let's take a look at example number 4. So here they're asking me, again, to find the perimeter. I've got to add up all my sides. So this guy, this guy, this one, this one, this one, this one. Lots of sides to add up.
So I'm going to say my perimeter is equal to 2x plus 3x minus 2 plus 3x plus 2x plus 1 plus 4x squared minus 2 plus 5x squared plus 3. Notice, that's a lot of stuff going on. Okay? So first thing I'm going to do is I'm going to ask myself, all right, what variables do I have? It looks like there's only x's. Good. That makes it a little bit easier. So I'm going to say, all right, sticking with my format of standard form, I start in alphabetical order. I only have x's, right? So now I'm going to look at all my x's, and I notice some of them don't have an exponent, so that means that they're a 1, and some of them have a 2 at the top. So I need to choose the ones that have the highest number. So that's going to be the guys that have the 2. So I'm going to go ahead and I'm going to circle those. I'm going to include the sign that's in front of them. Okay. So I only see 2 of them, 4x squared plus 5x squared. I have 4 of them here. I'm adding 5 of them together. 9x squared. Let me cross those off. All right. Simple and easy. Okay. So now let's look at the next one down. So I just did x to the power 2. So I want to do x to the power of 1 now. I'm going to do all the x's that do not have an exponent written there. Those are x to the power of 1. So I'll do those in black. I'm going to box those in. Here, 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 here. Okay, got all of them. So I have 2 plus 3 plus 3 plus 2. 2 plus 3 is 5, plus 3 is 8, plus 2 is 10, plus 10x. Let me cross them off now. Okay, so we made some progress here, but look at that. There's still some stuff that I haven't crossed off yet. Here, 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 and here. What are those? Well, they don't have a variable attached to them. Those are constants. So the other thing that we have to know about standard form is not only is it alphabetical, and then I do my exponents from big to small under each letter, but my constant is always last. Always last. All right, so let's go ahead and put those together. -2 plus 1, -2 plus 3. Okay, so -2 plus 1, that's -1, minus another 2, -3 plus 3, that's 0. Zeros always make me suspicious. So I'm just going to write that out again. -2 plus 1 minus 2 plus 3. Okay, so I'm going to put all the negatives first. -4 plus 4. So yeah, it is 0.
I don't have to write that one in. So this is my final answer for my perimeter. So my perimeter is equal to 9x squared plus 10x. All right, so I want you guys to go ahead and head over to example 5, and I want you to start there. It's asking you a question, and I want you to make sure that you get the correct answer. I'll give you instructions on how to submit this answer to me. This is going to be a very small point of credit for us. So, until our next lesson, this is goodbye, and let me know if you have any questions.